All right, I think this is working now. So let's get started. Today I'm going through a list of binary research questions. So the way that I want to go through it is I'm going to live stream me solving, or at least trying to solve all these questions on the go. This is for two reasons. The first being, obviously, I want to practice being live because like that's what the interviews are for. I want to have that a little bit of anxiety there, and then also like just to be very real with you guys, because um it's easy to see like a curated solution online and then feeling like you can't solve it on your own and like there's something's wrong with you. I certainly felt that way for a very long time until I really started paying attention to those creators previously submitted solutions. And it's like, if you really pay attention, you can see that questions like these or any lead code questions don't really come easy to anyone. It's definitely a lots and lots of practice and then repetition. So for that reason, like, this is me being super real and authentic and vulnerable, I guess, and hopefully all of us get something out of it. So in any case, let's get started. I have filtered these by the easies first. Once I'm done with the easies, I'll move on to mediums and then hards. At least that's how it is. If a particular questions have progressions, right? Like question like this one, like intersection of 2 arrays 1, 2 arrays 2. In that case, I would follow this particular progression instead of just relying on the list. So yeah, like this is pretty much it. Let's get started. Starting the timer because that is important. All right, now let's read the question. I'm given a sorted array, obviously, of distinct integers and target value. Return the index if the target is found. If not, return the index where it would be if it's inserted in the order. So this is like basic binary search. We should be able to solve it very easily. The question is the same. We're gonna have two pointers, left and right, trying to like close in on the mid, and in the mid try to find the target, right? So I can define my lefts and rights, which is going to be on both ends of the list. There we go. And once I have that, I want to continue until um, L is less than equal to R. I'm using less than equal here because if the target is not found, like this particular position would be where I would insert it. And yeah, so let's do it. So now M is going to be L plus R minus L divide by 2. So this is just our formula to get the midpoint. This one ensures that we never run into the out of bounds error. Once I have that, then I can just compare. So if my current M is the target, then I would return target. Otherwise, if nums of M, like my current value, is less than target, then in a sorted array, I know I should move towards the right. So my L is going to be M plus 1. And if that's not the case, then my R is going to be M. So in the end, now I have found my position where if I never find a solution, then this is where I should have inserted it, right? So let's go through this particular example where we have a target. My R and L are starting with 0 and 3, 0 and 3. And in this case, the mid is going to be 1. Right? And well, what's the 3 is at position 1, it's not equal to target. Then is it less than the target? It is. So what do? I change my L to be 2. and then calculating the mid again. So 2 plus 3. So, okay, so mid is going to be 2 here, and then the target will be returned. But on the other case, now if I'm searching for 2, the first case, obviously, I'm here. So I'm here, right? Like, this is what that would be triggered. Here, the R is going to be M, and my M originally was 1. So now this is 1, right? Now I go up there. Yes. So L is 0, R is 1. I go up there. My M is going to be, what is my M? M is 0 plus 0, basically. So M is 0. Now is target equals to 1. It is not. It's M is less. So what do? I change my L to M plus 1, which in this case is going to be 2. So now this loop breaks, and then we have to return L. All right, so let's try submitting it. Oh, the buildup. Oh my God. What? Oh, sorry. This is M. Because obviously we are returning the indices. Time limit exceeded. Do we have... I'm basically trying all different variations of it right now, which is wrong, obviously. I know this is not the right way, but let's keep doing it until we hit a solution, I guess. All right. Perfect. Complexity is n log n of it. And sorry, it's just log n, and memory complexity is O of 1. So time is log of n, and space is 1. Awesome. Well, not that awesome considering we have to play around with the conditions of the loop, but that is exactly why I'm going through this entire list, because binary search confuses me in deciding, like, oh, is it less than equal to or not? How do I move the right pointer if it's m minus 1 or just m, right? So I guess hopefully by the end of this list I know more. But in any case, this was all for today. So I hope you guys enjoyed it. And yeah, we'll see you in the next one, I guess. Take care. Bye.